Hello guys, in this session we will write a implementation for a little virtual machine in Python, and we are going to start by defining our class virtual machine. And our virtual machine of course has memory. And an instruction pointer which points to the instruction we want to execute. I'm going to set this to default to 0. And then we will define a step function which executes one instruction. Then we will fetch the current instruction and advance the instruction pointer. And now we will have to see what kind of instruction this is. And now we have to define some very basic instructions. We're going to say so we will define two instructions, one which just loads a 0 and another one which loads a 1. So then let's see. Okay. So our virtual machine has a stack, which we just use a basic Python list for. And if we encounter this instruction, we will push a 0 to the stack. And in this case, we will push a number 1 to the stack. Then we will execute two instructions. Okay, so we forgot to pass the memory parameter argument. Okay, so as you can see, we execute two instructions, and we execute this load constant 1 and load constant 1. And as a result, our stack has these two numbers 1 on it. And if you switch this to some load constant 0 and run it, you will have a stack that looks like this. Now, of course, we want to do some arithmetic, so we also define arithmetic functions. So in a stack virtual machines, the arguments to instructions are also on the stack, so we have to pop or remove two arguments from the stack, then add those two numbers together and push the result back to the stack. And we're gonna create the helper functions to do this. So say pop b for short for pop integer. So we just take the last element and then we remove it and return this. Also do the same for pushing integers to the stack. Because then we can rewrite this to self push integer. And here as well, self push integer. And now, since we push A and push B, means that B is on top of the stack. So we have to pop B first, then A. Then we push the result. So if we do this, we should see the result should be 2. We forgot to execute this instruction. Okay. Now let's define a function that steps as many instructions as necessary. Let's call it execute. And so we don't have to call step multiple times, we just call execute. Okay, cool. Now let's do the same for the multiplication function, multiplication instruction. So we need division and subtraction. And we also add an instruction called duplicate, which duplicates the element on top of the stack. Let's implement the duplicate instruction first. Which just pushes the same value twice again. So when we do this, we should see 2 2's on the stack. Great. So now we should have 2 and number 3 on the stack. And if we multiply this now, we should have a 6 on the stack. Now let's also create a print instruction, which just pops a value from the stack and prints it. This is basically to help us debugging. Okay. Right. Okay. So it prints 6 and the stack is now empty. Okay. Good. And now we want to add loops. So let's say we want a jump if not 0 instruction. Now our jump instruction also needs argument a target address, so we know where to jump to. Okay. And now if value is not 0, we will jump to address. Okay. So let's add another. Oh, this should be a constant one. Let's say we also add a helper instruction like this. Okay. And we also need to implement the subtraction instruction, of course, so we can subtract. Okay, so this is address 0. This instruction will be at address 0. This will be at address 1, 2, 3, 4, 5, and 6. Okay, so this will load the number 4. This will duplicate it. So our stack would look like this. Then we print the number and we subtract 1. Then we load the address where we want to jump to. We gotta change this. And if it's not 0, jump to not 0. And if we did everything right, this should print 4, 3, 2, and so on. Okay, so obviously this should be not the identifier 0, but the number 0. Okay, so we made some mistake somewhere. Um, There's line 39, 84. Okay, so here's what happens. This will also pop our value from the stack, so we need to save the value, which means we need an additional application. Now also the addresses are different. Okay. So as you can see, now we have a loop that loops down from 4 until it is 0, and it doesn't print the 0, of course, because we only jump back from here to here if it's not 0. Which means that this won't be executed if it is 0. Okay. And we can also add a jump instruction, jump if 0. Let's move this here. Jump if 0. I just changed the value from the instruction. So now we basically just copy this. And instead of if it's not 0, we jump if it is 0. And we can also add an unconditional jump. Where we jump unconditionally. And now we rewrite this to use the jump if 0 instruction. Okay. So this way we can emulate a while loop. So of course we also duplicate this again. Okay. Then we want to subtract 1 from it. Let's align this a bit better. Make it more readable. And now we check if it is 0. So we need to duplicate it again. So now the problem now is that we do not we need to figure out where we want to jump to. So if it is 0, we don't want to jump back, but we want to jump forward. But since this is at address 0, address 1, address 2, address 3, address 4, 5, 6, we want to jump somewhere here. But this is a bit annoying because we don't yet have an easy way to load an arbitrary number. We can load number 1, 0, and 4. So let's add another instruction such that we can load arbitrary numbers. Or at least somewhat arbitrary numbers. And we also load the value we want to push to the stack from memory. So we have to advanced instruction pointer. And we can check if this works by, let's comment this out. Now we want to load the number 35. Let's see if this works. Doesn't work. That's okay. Question now is, why does this not work? Okay, so it doesn't even load this instruction. This is weird. Okay, so I have to debug a little bit to see what's going on. Let's print it's trying to execute. Next F7. Okay. Which is kind of wrong. Because it means it's executing this instead of this, which is kind of weird. What the? Can I do this? Format, comment, mode region. And so we probably forgot this. Okay, so now it's correctly executed. I forgot a reference to self. So now it's correctly executing this, so I can remove this debug print statement, and then let's uncomment this again. Also, let's add a no operation, which is an instruction that basically does nothing, which we already added here. And we're gonna add this here. So at the end, we want to execute the no operation instruction. So basically what we want to do now is then this would be address 6, and this would be address 7, it's 8, it's 9. So, but we don't really know that yet. So we wanna, if it's 0, we wanna jump to here, wherever this will be. And if it's not 0, you wanna jump back to print loop. But then we also, of course, have to load that address, which we can do like this. So now we know that the end of our while loop is at address 11, so we have to load the number 11 here. And then let's remove this. And if we get everything right on the first try, this should, I forgot the comma, yes, that's right. This should be a while loop now. Okay. And this is basically the equivalent of so this code here does essentially this. Let's remove this print statement here. But now let's say we want to extend this so that we can write something like this, which means we need an instruction that can compare values. So we need two numbers, of course, and if a is smaller than b, we push a 1, otherwise we push a 0. Okay, so then let's comment this out again, and let's write so let's say we load 50 and 77 and execute our comparison, which is 1 because 50 is smaller than 77, and now we get a 0 because it's 78 is bigger than 77, of course. Okay, then we go back to our original code. Okay, so now we want to see if our number is smaller than 10, so of course we have to load the number 10, and you can do it like this. And then we need to make the comparison check. And this should be here, here. Okay, so this means that if it is 0, this means that the condition is false, because this instruction returns 0 if a is not smaller than b. So this should theoretically work already, I hope. But of course we should probably initialize this to 10. Or let's just, for simplicity's sake, let's say we want to do this. In which case I want to load 0. And instead of subtracting 1, we want to add 1. Let's see if we got it right. Okay, we almost got it right. So we made some mistake somewhere. Okay. Now, of course, this address has to be 14 now, because the end of loop and now we have written this while loop in machine code for, or bytecode, whatever you want to call it, for our virtual machine. Okay, so yeah. And now what we can do is we can basically we can add some helper functions. We can do this. Code. Needs to be a dot. And what else? Because now we can add some more helper functions to make it easier to write code. And we're going to call this emit. And of course, since this is only 1 byte, to add a check. Okay. And, let's return the current address. So basically what we now can do is itself. And if we don't have enough memory, we will just increase it. Okay, so now we can also add a function emit lines. Is it called trim? I'm not quite sure actually. Let's check. No, it's called strip. Okay. Emit self emit line. Okay. Because now we should be able to do this source code. Also, let's check. That we ignore empty lines. And we can also add comments if line starts with ignore it. Okay. So let's say you want to load this. Right. It's okay. Now we still have some error. At what line? 91. It's kind of weird actually, because let's add a debug print statement. Of course. Right. And now we want to see what this actually generates. So we print the memory. Okay, then let's check. So we have these instructions and the two add instructions, that's correct. But now we have to reset the instruction pointer to 0. And voila. Let's remove this and let's remove this. Don't need this. Okay, so we forgot this in the dictionary, the print instruction. And now it prints 3. And now, did we already define the multiplication instruction? Yes. Then we have to add this too. And now we can. Okay. So now for this takes an argument. So we have to make sure that we also do check if our text line has an argument. So we do this. If it's 1, then we do this. If it's 2, then we do this. Let's call this parts instead of arguments. This as well. It's also parts. Then okay. So now which means let's check if everything still works. So everything still works. It's 3. It's correct. And now let's try this, which means it should print 12. Okay, so that's actually not correct. Okay, I think we forgot to advance the instruction pointer. Yeah, okay. Okay, so and in part 2, in the next video, we will extend this code such that we can write things like this. So we want to basically add labels or functions or whatever you want to call it, and we want to add pseudo instructions, because these are not actual machines instructions, but these are instructions that our assembler understands. And we basically want to be able to, instead of having to calculate manually where the end and start of loops or functions are, we want to have our assembler or compiler or whatever you want to call it calculate the addresses and we want to be able to put names to addresses. And that's what we'll do in the next part. Okay, bye.